Section 2.3, Addition and Subtraction of Matrices. As you've probably noticed, matrices are a great way to organize data first. We can do a whole lot of things with matrices, as you saw before. We can multiply them, interchange them, add them together, etc. But we can also use matrices to add and subtract matrices themselves. But let's first talk about matrices size. So you'll see this first matrix here. This is a 3 by 2 matrix. And it's a 3 by 2 because we have a three rows by 2 columns. The next one over, we see we have 3 rows by 3 columns, so it's a 3 by 3. And the next one over, we have, let's see here, 1 row by 5 columns. And then finally, we have 3 rows by 1 column. So there's some things we need to talk about, some other items for vocab. A square matrix is a matrix such as a 3 by 3, meaning that the rows and columns are identical. A row matrix is when we have, or a row vector, is where we have just a single row. There's just a 1 by something. And then a column matrix is where we just have a one column item here. Matrix equality is when 2 matrices are of the exact same size and each corresponding element is the exact same. So if we look at these square 2 by 2 matrices, we have 2, 1, 3, negative 5, and 1, 2, negative 5, 3. Although they have the same exact elements, the elements aren't in the same exact location. So 2 doesn't match up with 2 here. So this would not be equivalent. So no, these are not equivalent because although they contain the same elements, they're not in the same location. We can add and subtract matrices only if they're their exact same size. So if we look at the 2 matrices down here, we have a 2 by 2 and another 2 by 2. So we're able to add them together, and all we do is add corresponding elements together. So we're going to take 5 plus negative 4. That would give us 1, and we'll continue down the line here. Negative 6 matches up with positive 6, giving us 0. 6 plus 8 gives us 14, and 2 plus negative 3 gives us negative 1. So we just added the matrices together. You try adding these matrices together. Pause the video, work through it by yourself, and play when you're ready. So we have a 3 by 3, and then, I'm sorry, not a 3 by 3, we have a 2 by 3. And we have another 2 by 3, so we're able to add them together. So we'll combine the corresponding elements. 3 plus 1 is 4. 4 plus negative 2 is 2. And 5 plus 4 is 9. 1 plus negative 2 is negative 1. 2 plus negative 4 is negative 2. And 3 plus 8 is 11. The same rules apply with subtraction. So again, we have a 2 by 3 and another 2 by 3, so we're able to subtract them. We do the same thing. We want to subtract the corresponding elements. Be careful with subtraction and negative numbers. So 8 minus 3 is 5. 6 minus 5 is 1. Negative 4 minus a negative 8 becomes negative 4 plus 8, so a positive 4. Negative 2 minus a negative 4, so again, subtracting a negative is the same as adding, so negative 2 plus 4 is 2. 7 minus 2 is 5. And 5 minus 9 gives us -4. Let's find the difference of this set. Here we have a 2 by 2. Oh my, the next one isn't a 2 by 2. This next one is a 2 by 1. Since they're not the same size, we're not able to subtract their elements, so we simply say not possible. Because they don't have the same amount of elements to compare with. David Cruzwa owns a car dealership in Minneapolis. The following matrix gives the number of vehicles sold in January. So it looks like we have new and used cars and trucks. So it says in February his new cars sales decreased by 2, but his new truck sales increased by 25%. His used car sales increased by 50%, while his used truck sales increased by 7%. Write the vehicle sales matrix for February. So we're going to have another 2 by 2. So his new car sales decreased by 2. So 17 decreased by 2 would give us 15. His new truck sales increased by 25%. Well, 25% of 12 would be 3, so if we increased by 3, we would also have 15. His used car sales increased by 50%, so 24 times 50% would be 12, so they increased by 12, so 12 plus 24 is 36. While his used truck sales increased by 7. 18 plus 7 gives us 25. We're going to refer back to this page here for letter B and C, so hopefully you write these down. We'll go back to it. Write a matrix that represents the total vehicle sales over the 2-month period. So our first for January is given to us. We have 17, 12, 24, and 18. And then if we want to add that to what he earned in February, we had 15, 15, 36, and 25. Well, again, we can add our corresponding elements. So 17 plus 15 gives us 32. 12 and 15 gives us 27. 26 plus 36, or 24 plus 36, excuse me, gives me 60. And 18 plus 25 is 43. Write a matrix that represents the change in sales from January to February. So if we compare to get from January to February, the change from 17 to 15, we subtracted 2. The change from 12 to 15, we added 3. The change from 24 to 36, we add 12. And the change from 18 to 25 is 7. So this represents the change in sales from January to February. And this concludes section 2.3.